Alright, ladies and gentlemen, in this video we are going to focus on inequalities in two triangles. Specifically, we are going to define and utilize what is known as the Hinge theorem, both in application and in proof. So let's take a look here first and foremost. So I have a diagram which y'all think about. So if you think about a fence gate, or just any door specifically, think about what happens, right? In this first example, I barely open on up the gate, right? I barely open on up the gate, and what ends up happening? You create an angle A down here that is pretty small, right? The small gate produces a small angle at the hinge, right? I open it up a little bit more. What ends up happening with angle A? Well, it gets slightly bigger as I open it up right through here. And then notice when I open it up all the way and the end of the gate is somewhere over here by point C. What ends up happening to angle A? Well, now you create a huge obtuse angle. And so what we're basically saying is that notice the comparison. BC is small, the opposite angle A is small. BC is getting a little bit bigger, so the angle A gets a little bit bigger. BC is its biggest point, and it is its biggest angle measure opposite at A. So the bigger the angle, the bigger the opposite side. The smaller the angle, the smaller the opposite side. And that is our hinge theorem. Specifically, in this scenario, what we can say here, guys, is if there is an angle that is placed in between two pairs of congruent sides, as you see here. Vx and RT are congruent, VW and RS are congruent. If an angle is placed in between or is included, all right, of those two pairs of congruent sides, then I can make the statement for sure that Wx is bigger than ST because the angle V is a greater angle measure than the angle R right here. Okay, the converse holds true as well. I can also say that if the side length is bigger, I can definitely make the claim that the angle is then bigger, that is opposite of that side. So angle C would definitely be bigger than angle F because AB is bigger than BE. All right, so let's use this in a little bit of kind of a little proof action, I guess, more or less. So it says, using the converse of the hinge theorem. It says, given that ST is congruent to PR, how does the measure of angle PST compare to the measure of angle SPR? Well, we first and foremost want to put ourselves in the position to use the hinge theorem. So I want to make sure that we talk about that first and foremost. So the position is getting these two pairs of congruent sides. So first and foremost, what do we know? All right. Well, it is given. Right. It is given. I'm doing more paragraph proof here. It is given that PR is congruent to ST. All right. So we know that. All right. For sure, we know that. By the reflexive property, what do I know? Hopefully we see those shared sides. By the reflexive property, I can say that PS is congruent to SP. This is important. Now I've decided that I do in fact have the hinge theorem in play. So now I can go ahead and utilize what I know about these two sides. Okay? So since 24 is greater than 23, I can make the claim that PT, this side right here, is bigger than RS. I can say that PT is bigger than RS. And if that's the case, the converse of the hinge theorem tells us that P and S, all right, have a relationship now, okay? So by the converse of the hinge theorem, angle P, all right, angle P is what? Well, angle P would be less than, actually, let's get a little bit more specific. I don't want to just say angle P. Hold on, I'm sorry, guys. I don't want to say just angle P. There's a couple angle P's. I can say that the measure of angle PST T is greater than the measure of angle SPR. Didn't want to just say the one vertex because that wasn't going to fit. So I can kind of almost say a little bit more of a proof using that hinge theorem.